Transformers. Transformer is a device that changes, transforms, alternating potential difference, voltage, from one value to another value. It works on the principle of electromagnetic mutual induction. A transformer consists of two sets of coils insulated from each other. These coils can be wound either on separate limbs of the iron core or be arranged on top of each other. Let one of the coils, called the primary coil, has Np turns. The other coil, called the secondary coil, has Ns turns. Often the primary coil is called the input coil and the secondary coil is called the output coil of the transformer. When an alternating potential difference is supplied to the primary, the resulting alternating current in the primary coil produces a changing magnetic field around it. This changing field induces an alternating current in the secondary coil. The voltage induced in the secondary coil depends on the number of turns in the secondary coil. We consider an ideal transformer in which all the flux in the core links both primary and secondary windings. Let phi be the flux in each turn in the core at time t due to current in the primary when a voltage Vp is applied to it. Then the induced EMF or voltage epsilon s in the secondary with Ns turns is epsilon s is equal to minus Ns d phi by dt, equation 1. The alternating flux phi also induces an EMF called back EMF in the primary. This is epsilon p is equal to minus Np d phi by dt, equation 2. But epsilon p is equal to Vp. If this were not so, the primary current would be infinite, since the primary has zero resistance as assumed. If the secondary is an open circuit or the current taken from it is small, then to a good approximation, epsilon s is equal to Vs, where Vs is the voltage across the secondary. Therefore, equation 1 and 2 can be written as Vs is equal to minus Ns d phi by dt, equation 3. Vp is equal to minus Np d phi by dt, equation 4. From equation 3 and 4 we get Vs by Vp is equal to Ns by Np, equation 5. The above relation is based on three assumptions. 1. The primary resistance and current are small. 2. The same flux links both the primary and the secondary. 3. The secondary current is small. If the transformer is assumed to be 100% efficient, the power input is equal to the power output. IPVP is equal to ISVS, equation 6. A well-designed transformer may have an efficiency of more than 95%. Combining equations 5 and 6, we get IP by IS is equal to Vs by Vp is equal to Ns by Np, equation 7. Let us see how the number of turns in transformer affects the voltage and current. we have Vs by Vp is equal to Ns by Np gives Vs is equal to Ns by Np Vp. Ip by Is is equal to Ns by Np gives Is is equal to Np by Ns Ip. If the secondary coil has a greater number of turns than the primary, Ns greater than Np, the voltage across secondary coil is more than the input voltage across primary coil. Voltage is stepped up. Vs greater than Vp. This type of transformer is called a step-up transformer. However, in this arrangement, there is less current in the secondary than in the primary. That is, Is is less than Ip. If the secondary coil has less number of turns than the primary, Ns is less than Np, the voltage is stepped down. Vs is less than Vp. This type of transformer is called a step-down transformer. In this case, Vs is less than Vp and Is is greater than Ip. That is, voltage is reduced and the current is increased. The relations obtained between voltage, current, and number of turns are applicable only in case of ideal transformers. But in actual transformers, some energy losses do occur due to the following reasons. 1. Flux leakage. There is always some flux leakage. It can be reduced by winding the primary and secondary coils one over the other. 2. Resistance of the windings. The wire used for the windings has some resistance and so energy is lost due to heat produced in the wire. I square R. In high current, low voltage windings, these are minimized by using thick wire. 3. Eddy currents. The alternating magnetic flux induces eddy currents in the iron core and causes heating. The effect is reduced by having a laminated core. Hysteresis. The magnetization of the core is repeatedly reversed by the alternating magnetic field. A small amount of energy is lost due to hysteresis within the core. This energy loss can be minimized by using a magnetic material which has a low hysteresis loss. Transformers are used to increase or step up the voltage before transmitting electrical energy over long distances through wires to an area substation near the consumers. There, the voltage is stepped down. It is further stepped down at distributing substations and utility poles before a power supply of 240 volts reaches our homes.